We've discussed a lot of properties of gases in this unit and talked about a lot of foundational concepts relating to this course in general. The final concept we need to discuss is how gases can move, as well as how combining gases can affect the property of pressure. If you've ever walked out of a plane or a building with a tight door, you might feel a breeze. This is partly due to Graham's law of diffusion. Diffusion refers to the passive or natural movement of stuff. In this law, Graham figures out that the gases will passively move from an area of high concentration, or more stuff, to an area of low concentration, or less stuff. If you take in living environment or biology, you may recognize this as a very similar concept to how certain things can move across our cells, also from high to low concentrations. One other law we can consider refers to how the pressure can be calculated when we have multiple gases in one container. In the past, we only considered the pressure when one type of gas exists in a sample. But what if we have multiple gases at once, like maybe oxygen and nitrogen? What this guy Dalton figured out is that the total pressure of a container is equal to the combined individual pressures of each gas. This is called Dalton's law of partial pressures, referring to the individual or partial pressures of each gas. For instance, if the pressure of oxygen was 200 kilopascals and the nitrogen is 100 kilopascals, the total pressure would be 300 kilopascals. Pretty simple. These two concepts conclude Unit 1. You've learned a lot this unit, from sig figs and scientific notation, all the way to the kinetic molecular theory and other ideal gas concepts. Check out the description below for free worksheets and answer keys for each concept, and explainer videos to go along with the worksheets. See you guys in the next unit.